Okay, so for today, we are going to talk about line segments and distances. Our understanding goal for the day is that I understand the difference between lines and segments and the betweenness of points. Basically, when we're talking about points being between other points, we call it the betweenness of points. Betweenness isn't really a word, but we are going to use it for this. Point M is between P and Q only if P, Q, and M are. So this is our line here. P, M, and Q are on that line. And we're trying to prove that M is between P and Q. Well, that's only true if they are collinear. Oops. Let me fix that. Oh, it's still too big. Collinear, meaning all of those points are on the same line, and PM plus MQ equals PQ. Now, I'm not going to get into this right now because I'll get into it a little bit more in class, but just off the top of my head here, I'm not actually going to put these line segments on top of these. And the reason for that is because we have an equal sign here. And I'll have to get you caught up on that when you get back. But when we are putting these in like an equation like this, we actually don't put the lines on top. So C lies between B and D on a segment. Given BC equals 16.8 and CD equals 50.4 millimeters, find BD. So if C lies between B and D on a segment, that means B is here, D is here, and C would be between them. And I should have drawn a straighter line, but that's the best I can do right now. So C is between them. BC, it says, is 16.8 millimeters, and CD is 50.4 millimeters. So it wants BD, it wants the full length. Well, to get the full length then, we just add those together. 16.8 plus 50.4, let's see, 0.2, it's going to be 67.2 millimeters. Find the value of N and WX if W is between X and Y. So if W is between X and Y, it wants the value of N if WX is 6N minus 10. WY is 3N. I just took this one. Or 3N. And XY, which is the whole thing there is 17. In order to get that, we're going to have to set up an equation. 6N minus 10 plus 3X. Basically what I did there is I took this one and added it to this one, and I know that those two should add up to equal the whole thing, so equals 17. I don't know why I changed to X. I wasn't supposed to. It should be an N. I'm not going to go through that right now, but you are basically going to solve for N on that equation, and then you'll get your final answer. Next, if two geometric figures have the same exact shape and size, they are congruent. Congruent is a massive vocab word that we need to get down. Congruent segments have the same length. This is the congruent symbol. It looks like an equal sign with a little squiggly at the top. It's called a tilde. You read it as is congruent to. Red slashes on the figure, they don't have to be red, but something like this and this show congruence. They're just like tick marks. I like to call them tick marks, but I don't know if they have a real name. Example. So an example maybe AB is congruent to CD. That's how I would write that. AB is congruent to CD. When we have congruent, we do need to put these on top. I set up top here that since we had an equal sign, we don't have to. That's the main distinguishment. We don't need to do the line over the top here because there's an equal sign, but if it was congruent, you would have to. All right, find the distance between K and L on the number line. This is pretty easy because you can just count, or you can figure out the difference if you take like 11 minus, or negative 11 minus 11, negative 2 minus negative 11 can get you the answer there. That's going to be a positive 9. So there should be 9 spaces between those. Distance formula. Talking about the distance formula, I'm not going to get into this too much on this video because I want to make this video short and sweet. But the distance formula is this thing, and its goal is to find the distance between any 2 points. You have x1 and y1, that's one of your points. And then your other point is y2 and x2, or x2 and y2. So you have to pick your 2 points, like for example, on the next problem, this is one of them, this is the other one. Figure out what those points are and just basically put them into that equation. The distance formula comes from the Pythagorean theorem, but I'm not going to get way into that right on this thing. So distance formula here. So let's just, we can call these x1, y1, x2, y2, and we're just going to basically plug them in. So I'm starting here. What was my x2? Well, it was a 1. I'm putting it in parentheses. Minus x1, which was negative 3. Make sure you do the negative 3. Square it. Plus, our y2 was 2. Minus our y1, which was 4. Make sure you square it. And we can go from there. So this in here, 1 minus negative 3 is 4, because this becomes a plus, right? 4 squared is 16. I'm going to keep my radical there. Plus, 2 minus 4 is negative 2, but I'm squaring it, so I'll get a positive 4. 16 plus 4 is 20. Square root of 20 is kind of my final answer, but it asks for an exact answer. The way that I'm taking that means we have to simplify this radical. So if I'm simplifying this radical, I'm going to separate it into the square root of 4 and the square root of 5, because 4 times 5 is 20. Then I can actually simplify the square root of 4 to a 2. My answer is 2 root 5. Ben is standing on the 40-yard line, 20 yards from the sideline when he throws the football. Eric catches it on the other team's 30-yard line, 10 yards from the sideline. How far did Ben throw the ball? Round your answer to the nearest hundredth. So Ben is standing at the 40-yard line. So let's just draw a football field. 40-yard line, we'll call this the 50, so maybe the 40 is right here. 20 yards from the sideline, so right here. This would be 20 yards. When he throws the football, Eric catches it on the other team's 30-yard line. So this would maybe be the 30. 10 yards from the sideline. We'll call this 10. How far did Ben throw the ball? So basically, if he threw it on this path, he threw it only 10 yards towards the sideline, But this would be the 40, the 50, the 40, and the 30. That looks like 30 yards this way and 10 yards this way. And this was the flight of the ball. So then we got to figure out what that flight was, how far he flew the ball or threw the ball. So to do that, I would just use the Pythagorean theorem. We have our like sides, so the Pythagorean theorem is going to be easiest. So I would say 10 squared plus 30 squared equals c squared, because those are my two legs. 100 plus 900 equals c squared. 1,000 equals c squared. C must equal 100. No. What's the square root of 1,000? Oops. Sorry, guys. Am I having a brain fart here? Let me check. Square root of 1,000. Grabbing my calculator. Okay, you know, it's not an even number. I thought it might be, but it's not. So we would have to actually separate that. So, sorry. I'm going to bring my work over here to just finish this up quick. I know that 100's a perfect square. So really what I'm at here, I would have to square root both sides. So I need the square root of 1,000, which I know is the square root of 100 times the square root of 10. Square root of 100, that is a perfect square. So that would be 10. And I'll just put that right here because we can't simplify that other 10. Maybe I'll write my final answer once more. It's 10 times the square root of 10. All right, sorry about that. It's been a long day. Thanks for watching this.